Hi everyone, welcome to Math Tutoring. Today's lesson is on factoring trinomials. So I'm just going to show you a quick rule. So trinomials are usually in the form x squared plus a plus b x plus ab. So when you're factoring a trinomial, what you're going to look for is x plus a, x plus b. So basically you're going to want the sum, the number that's in front of the x, a and b have to add up to that number. So a and b have to add up to this number, so that's the sum. And then they have to multiply to this number, so that there is the product of a and b, okay? Sometimes, or another way, or we could just think of two numbers that add to the middle term. I usually remember it this way: x squared plus something x plus b, say. So another way to remember, which is what I usually do, is I think of two numbers that, when I want to factor a trinomial, I think of two numbers that add to the middle term, the number in front of the middle term, and multiply to the last term. Okay, so I used to remember this as AM, which represents the morning. So I used to remember that two numbers add to this term and two numbers multiply to this term. Okay, so that's another way to remember. So, and I'm going to show you an example of what I'm talking about here. So say I had, if you want to factor this trinomial, so trinomial is in the form x squared plus some number x plus a number. Okay, so this is what a trinomial looks like. You have three terms, and you've got an x squared, an x, and then a number. Okay, so if I want to factor something like this, I'm going to think of two numbers that add to the number 8 and two numbers that multiply to the number 15. It has to be the same two numbers though when it factors this thing. So what you're going to do is you're going to think of two numbers that add to 8 and two numbers that multiply to 15. So right off the bat, 3 and 5 add to 8 and multiply to 15. So what I do is I just write this as x plus 3 and x plus 5. Okay, and that's how you would factor a trinomial like that. Okay. So an easy way to factor. So you always think of two numbers that add to the middle term and two numbers that multiply to the last term. So that this would be it. And if you FOILed this out, you would end up back at this answer. Okay, so that's factoring trinomials. We can do a whole bunch of examples. So let's try a few more here. So let's try, what if we had a negative? Like say we want to factor the trinomial x squared minus 6x plus 8. Now in this case, again, I need two numbers that add to negative 6 and two numbers that multiply. The same two numbers would have to multiply to 8. So they add to a negative and multiply to a positive. So if they add to a negative number and multiply to a positive, first of that must mean that they're both negative. And then we think of the numbers. So which two numbers add to 6 and multiply to 8? Well, if I think of multiples of 8, I have 1 and 8, but that doesn't add to 6. And they both have to be negative, so I think, okay, well, 2 and 4 multiply to 8, and yes, negative 2 plus negative 4 is equal to negative 6. So those would be my answers, okay? So then you would go ahead and put them in. So it would be x minus 2 and x minus 4. Okay, so that would be your answer there. Okay, so we can do another couple of examples here. So say we tried a different example. So we had x squared minus 2x minus 8. So this time we want two numbers that add to negative 2, but this time they multiply to a negative. Well, if two numbers add to a negative and multiply, first of all, if they multiply to a negative, one of them must be negative and one must be positive. So right off the bat, you can figure out the signs by if they multiply to a positive or negative, and then look at the other number. If they add to a positive and they multiply to a positive, they're both positive. But if they multiply to a negative, but they add to it, multiply to a positive and add to a negative, then they must both be negative. Now in this case, they add to a negative, but they multiply to a negative, so one's negative, one positive. If they also added to a positive and multiplied again to a negative, again it would be one negative, one positive, okay? So as soon as it multiplies to a negative, you've gotten one negative and one positive no matter what's happening up here. However, if it multiplies to a positive, you have to check what's going on over here. So if this is also positive, they're both positive. However, if this is negative, then they're both negative. So that's the 4 different situations you can have, okay? So you've got adds to -2 and multiplies to -8. Well, think of numbers that multiply -8. Right away I'm thinking 2 and 4. And yes, I can get them to add to -2 if I make the 4 negative and the 2 positive, okay? Okay, so right off the bat, I find my answers there, and I can go ahead and put them in. So it's going to be x minus 4 and x plus 2. Okay, so that's how we would factor that one. And if you actually foiled this back, you would end up at this answer. So let's try a few more examples. Okay, let's try something like this. So factor the following. Okay, so here we want 2 numbers that add to +2 and multiply to -15. So one's positive and one's negative since they multiply to a negative. So one negative, one positive. So I right away think of the numbers 3 and 5, and if I make the 3 negative and the 5 positive, I do end up at +2. So that one would be x minus 3 and x plus 5. So when you come up with the numbers, you have to be careful, because if we had put the 5 in front of the negative, then and the 3 here, then our sum would have been -2, so that would not have been correct. Okay, so you have to be very careful here to get exactly this situation when you're factoring. Now, what if you had an example where you had, say, a number in front of your first term? Like, say you had something like, actually, or even something like, let me see here. Okay, actually, I'm going to try something else here. Just give me a second here. So let's say you have 2x cubed plus 4x squared minus 30x, okay? You're asked to factor something like that. So what you're going to do here is you're going to first, if you have something like this, it's not in our usual format here, okay? So we can't use the same rules. So what we're going to do, it's not in our like this type of trinomial format. So over here we've got, yeah, so if you have a power of higher than 2 in your first one, you might have to factor something out to get it in this form. So in this case, okay, before you use this rule, you have to take out any common factors. So if you look here, what's common here that you can factor out? Out of the numbers, you can factor out a 2, and that's the greatest common factor. And out of the x's, you can factor out an x. So when you do that, you're left with x squared plus 2x minus 15. Okay, so as you see, you can factor this. So this is, you can go back to my video on factoring expressions to remember how we do this. But we take out the greatest common factor out of each term. So for the numbers, the greatest number that would divide all of these 3 numbers is 2. And then for the variables, the greatest variable that would divide all these would be x to the 1. So we go ahead and divide that out. Factoring out, when you do that, you divide it out. So you divide each thing. So 2x cubed divided by 2x gives me x squared. 4x squared divided by 2x gives me 2x. And then negative 30x divided by 2x gives me negative 15. And then at this point, you can see if you can factor this. So you'd need 2 numbers that, oh, okay, so now we've got the same thing as up here. We've got 2 numbers that add to 2 and multiply negative 15. So that was negative 3 and 5 from the previous example. Okay, so that would be the answer there. Okay, just 1 minute. Okay, so let's try another example. Okay, so for this type of example, we can go ahead and factor this, but what we're going to see is when we do factor it, instead of having x and x, we're going to have x cubed here. Okay, so we'll have x cubes instead. So we want two numbers that add to -1 and multiply to -6. So right off the bat, that would be -3 and +2. Okay, so you go ahead and put those in, and you're done. Okay, so that's how you factor something like that. So what if you had something like x to the 2n plus 5x to the n plus 6? So in this one, my exponents are going to be x to the n and x to the n. And then I just do normal factoring. So I want two numbers that add to +5 and multiply to +6. Those two numbers would be +2 and +3. So I put those in and I'm done. Okay? Okay, so you get the gist of that. I can do another complicated one. So if you had x to the, sorry about that. So if you had x to the 6n plus 2x to the 3n minus 3. For this, again, you're going to have x to the 3n and x to the 3n. So your exponents are going to be actually whatever you got here, okay? So same thing that we did here and here. So it's going to be the middle one. And when you add them up, or when you multiply them, I should say, by each other, you should get this one, right? So then you want two numbers that add to +2 and multiply -3. So they multiply to a negative, add to a positive. So I'm going to say that's going to be +3 and -1, and that would work. So +3 and -1. Okay. So that's how you factor that one. We could do a few more examples. So you had something like the following. If you had x plus y to the 2 plus 7x plus y. I'm going to take out this part right here. Okay, and plus, let's go back here. In this part we have -30. Now in this case, as you see this here, you could just think of that as your x. So when you factor it, this trinomial, you're going to have x plus y in here. Okay, so that's going to be x plus y. And then again, you want two numbers that add to 7 and multiply to -30. So that's going to be one positive and one negative. And I would say I would go with +10 and -3. So those two numbers multiply to -30 and add to 7. So you're going to put +10 here and -3 here. And that would be the factored form of that one there. Okay. So I'm going to do another lesson on factoring quadratic trinomials, and those are examples where you've got something like, 2x to the 2 plus 5x plus 3. So situations where you've got something like this and you can't factor it out. Actually, okay, you know what? Let's start that lesson right now. Now, what if you have something like this? So those ones were regular trinomials. Now this here is a quadratic trinomial, and what that is basically you've got a number in front of your x squared term. And if you look at this, you cannot factor this. There's nothing I can take out common out of all three, and I've got a trinomial. So now you've got a different situation, okay? So different rules to factor something like this. The ones where there's nothing in front of your x squared is easier to factor. Now over here, what you're going to do is you're going to think about, again, two numbers that add to the middle term, 5, but this time you want two numbers that multiply to 2 times 3. So it's going to multiply to 6, okay? And we did that by doing 2 times 3. Okay, so those two numbers would be 2 and 3. So what you're going to do is you're going to take this thing and you're going to replace the middle term with 2x plus 3x. Okay, so a totally different method here, factoring quadratic trinomials. So you're going to replace the 2x and the 5x with 2x and 3x, and then you're going to see what you can take out of these two that's common. So in this case it would be 2x, and then you'd be left with x plus 1. And over here you think of what you can take out of there, it would be 3, so that would be x plus 1. And then at that point you can factor out the x plus 1, and you'd be left with 2x plus 3. So that's how you'd factor something like that. Okay, but we're going to actually, I'm thinking we might do a separate lesson. So this is actually factoring quadratic trinomials, and I will be doing a separate video on this topic. Okay, so that's just a little bit of an intro, but I will continue this in a different or we could just group it. Let's group it together. So that's the first example there. So that's how you would solve something like that. It's a totally different method. Yeah, actually no, it is a little bit different. So I'm gonna put a separate video on that one. And this right here, factoring regular trinomials, very straightforward. However, factoring quadratic trinomials a little bit different. So this will be done in another video. Okay, so for this lesson, I hope you just understood how to factor basic trinomials where there's nothing in front of the x squared, a little bit more straightforward. And then we will be doing a lesson on factoring quadratic trinomials. Okay, so I hope that helped you understand the topic.